So we're going to be looking at tables on how to solve equations, and then we'll also look at how to algebraically solve linear equations. So let's start off with a table. So our equation is going to be 2x minus 5 equal to negative 7. So now let's make a table over here. And so we have x here, and then we're going to have our expression 2x minus 5, and we're going to start at negative 3 and go all the way up to 3. So, okay, so we're going to put all these values into this equation to see which one actually gives us negative 7. So we start with 2 times negative 3 minus 5 equal to negative 7, which gives us negative 6 minus 5, which is equal to 7. So that's negative 11, which doesn't equal negative 7, but it is our value that we got. But we're looking for the value that gives us negative 7. So I'll go on to the next one. That's 2 times negative 2 minus 5 equal to negative 7. That's negative 4 and negative 5 make negative 9, which does not equal negative 7. So that's negative 9. Let me go on to the next one. 2 times negative 1 minus 5 equal to negative 7. That gives me negative 7 equal to negative 7. That's true. That's working. So here is my solution. But I'll continue just so I can see what's going on. But as I look, I can see from going from here to here, I'm just adding 2. Right? And I made a mistake, so I'm going to do an undo here. Okay, and we'll move the screen down because I somehow bumped it. Alright, there we go. And so I can see by looking at this that this is increasing by 2. Because if I add 2 to the negative 11, I get the negative 7. If I add 2 to the negative 9, I get negative 7. And so if I add 2 to the negative 7, I'm going to get negative 5. And then add 2, I'm going to get negative 3. Add 2, I get negative 1. Add 2, I get 1. But then my answer is right here. And I didn't circle that very nicely. But this is my answer right here. So I now know that the solution of 2x minus 5 equal to negative 7 is x equal to negative 7. Or negative 1. Okay? And so this is how you solve a linear equation using a table. And so you'll get several problems like this in the homework and quizzes to do. So this is just a nice example, but it's very tedious and can take a long time. Now, if this had been a fraction, I would have probably not guessed the right x value to put in. So that's also another reason why we like to solve equations algebraically. So let's do that. So I'm going to solve an equation algebraically. Let's use 10x minus 13 equal to 0. And so I'm going to solve this algebraically. But to do that, I need to have the understanding and memorization of the order of operations. So I need to know this by heart. Okay? So the first thing I need to know is that I always do parentheses or brackets first. So whatever inside the parentheses and the brackets, that's what I have to do first. And in this case, I don't have that, so I'm not going to worry about that. Second step is I have to do exponents. So exponents are another thing I have to consider. That would be something like 3 to the second, or negative 4 to the third. This is my exponent here. And so I don't see anything in this particular problem, so I don't have to worry about that, but I would have to take that into consideration. My third step that we take a look at is multiplication or division, left to right. Okay? And so if I look for that, then I need to do that as well. And I do see multiplication going on here, so that's going to be something I'm going to do. And then the fourth step is addition or subtraction left to right. And so I do see that as well here, the minus 13. Now, the thing about the order of operation is this is working when you know all the numbers. So in this direction is the way I go when I know all the numbers. So that's important to know. Now, when I don't know all the numbers, in this particular case, that's the case, I actually go in this direction. So I do not know all of the numbers. And that's the case here. So I'm going to be going in this direction, and we call that the undoing. An undoing is basically, hey, whatever I see, I'm going to do the opposite of what I see to undo it. And that's the case here. So in this particular problem, I see that I see a minus or subtraction in the problem, so I'm going to undo it. And the undoing is to add 13 to both sides. Add 13 to both sides. And so by doing that, I'm undoing it to both sides of the equation here. This is the right side of the equation, this is the left side of the equation. So now I get 10x equal to 13 because this goes to 0. And I don't include it, don't need to. So then I go to my third step. I see that there is multiplication here. This is multiplication here. And so that is got to be taken care of. So we do the opposite, undoing, which is dividing by 10. Dividing by 10. Now we can write it this way, or we could do the reciprocal. We could write it as 10x equal to 13 and do the reciprocal to the side, which is 1 over 10. 1 over 10. These both mean the same thing. So this causes it to be canceled to 1. That's what this cancels to 1. And then I just have x equal to 13 tenths. And so here is my problem. Now I can also check it to see if my answer is correct, because I think maybe I did too many steps, I might have made a mistake. So I can do a check. And so now I put 10, and then x, I solved it to be 13 tenths. So 13 tenths minus 13 equal to 0. Well, 10 times 13 tenths, that cancels because that's over 1, gives me 13 minus 13. And so now I get 0 equal to 0. And since both numbers on the same side are the same, it's correct, which means my answer is correct. Okay? So that's basically how you solve some of the problems algebraically for linear equations.